So hi everyone, this is the compression decompression portal that I have made, and this is the deployed site. I have deployed its front end on Vercel, as you can see, and the back end on render. So yeah, so this is the home page where we have two options, first for compression and then decompression. Right now I have four algorithms for compression decompression: Huffman, LZ77, LZW, and RLE. And these are the recent jobs. These are some placeholder uh, buttons or icons, you can say. So yeah, so and this is the visualization page where I have gathered all the data that have been processed uh, in this website. I have stored these all in my database, and from after fetching these data, uh, I am showing this. Like in my database, all the any user who is doing any compression or decompression job, these are stored in the database, and using these data I am making these charts. So this is the average compression ratio of any algorithm. There is the speed versus memory usage. In speed, here I have defined as the what is the time consumed in processing the specific file. And memory usage, basically I am meaning the what percentage of the RAM is used for this particular job. And this is the effectiveness with respect to file type, like for photos, documents, and it is coming as greater than 100 because I have defined my compression ratio as original file size over the compressed file size. So it is normally greater than 1, so this percentage is also greater than 100. So yeah, this is the performance analytics. Then I have algorithm comparison. This is the overview, like for space saved. The as you can see, LZW gives us maximum percentage of space saved. Speed, here again we are considering this MPS. Basically it is the for any, suppose we have a file of 100 MB, and to process that we have consumed like 100 second, so our speed is basically 1 Mbps. So like this I have defined the speed. Memory usage, again the how much memory in the RAM we have used. This is the complexity, and this is the best use case, like in which type of files it is best to use. These are the overall performance score, and to calculate this score I have calculated using a specific formula. Basically I have put some weightage to this value: space saved, speed, CPU, and my code I will show later. I have my code here, so I'll show it later. This is the performance analytics. Like for different algorithms I have made these bar charts. This speed versus compression efficiency. This is the heat map. Then I have learning resources for users. Here I have attached like these are, for now these are some placeholder, so in future I will be adding some YouTube video link here or some pop-up to show up where user can learn through some videos, etc. And these are some online resources that I have mentioned, like user can go here and learn about these resources, these algorithms more. And uh, for users more interactivity, I have added this progress bar. If if the user has completed this resource, he or she can mark it as completed, and accordingly the progress bar will keep on increasing. And yes, these are some roadmap, like some normal simple roadmap to guide the user to learn this algo. And these are my details for various algorithms, like Huffman coding, their advantage, disadvantage, real life application, and if you wish to learn more, then I have attached the Wikipedia link where user can go and learn more about this. Also, I have filtering for different type of algorithms. Like for statistical we have these two algorithms. For dictionary type data we have this basic, hybrid, transform, perceptual, video modern. Also we have this search, like if I search for Huffman in my all category, then I am getting this. If I am searching for LZ77, then I am getting this. Yes, like this. So this is my visualization page, and this is my dashboard, like for user dashboard. So here the user specific data are mentioned, but now as you can see I am not signed in. So if I click on this dashboard, it should redirect me to sign in page. So let us see. Yes, it is redirecting me to sign in page because I have not signed in, and I am going to user dashboard. So before that, let us see some other feature. Okay, so as you can see, this is my home page. Now I am not signed in, and let us try to compress some file. So select any file. Please note I am not signed in. So now if I try to compress my file, it should say that you have to sign in to compress any file and redirect me to sign in page. So if I compress, yes, you must be logged in to use this feature, and I am redirected to this page. So let us try to sign in. I'm doing using GitHub. You can do using your Google also. It is redirecting me to the dashboard page for the user dashboard. Yes, so this is the dashboard page where you have different type of this visualization tools. This is the total compressions, how many compressions you have made, and these trends are like for this it is real, but some quality score, active jobs, this active job is not is there for some, it is like placeholder value because I have not implemented its logic right now, and rest all are like original values. The storage saved, compression, total compressions, data processed, average compressions, success rate. Like here you can say I am getting these compression jobs. Here the all the results from the API that I am getting, and I am using this data here. Okay, these are like day wise, like on June 20, June 22, and June 24. That is today. So today I have made one compression. Let us make another compression and come back to this page. This is the storage saved. This is also some recent jobs I am showing you. These are failed. For some reason this compression was failed. These are some placeholder buttons. For now these are placeholder buttons, but in future I'll be making these buttons functional as well. So let us try to compress any file. Okay. So this PDF I am choosing LZW, and let us have a look at this network tab. Compress file. First it is calling my API to the backend for compressing the file. This is my backend server. Currently I am using render, so it is the basically the server goes on sleep mode after every 15 minutes, so it is causing a delay in response. You can see the response for compress basically from my backend. This is the file name, this is the compressed base 64, original size, new size, compression ratio, times in millisecond, CPU का percentage, memory used in bytes only, metadata, algorithm success. And these are the compression jobs. Basically this compress this response I am getting from my backend, and this compression jobs is when I am redirected to this result page with my specific job ID. I am fetching this job to fetching this job from my database and showing this data. So here I have this download option, download the compressed file. Here you can download it and see it later, see. And if you want to copy this job ID, you can copy and paste it anywhere else. So here this original file, the file name was this, original size was 32.4 KB, the reduced size is 31.4, the reduction in size is this much. This 106 millisecond was taken to process this job. This was the speed, this was the memory usage, the RAM usage. Here this compression ratio is 1. Basically it is rounding off. The compression ratio was actually 1.07, 1.03, sorry, 1.03. So it is rounding off to 1. And these are some basic information. So from here you can go to your job. Now let us see our dashboard. See, on 24th we have 3 compressions, like recently, previously we had 2, now we have 3 because recently we have made 1 compression, and in recent jobs also it is showing, and the date is also shown here. So yeah, basically this is the UI part. And similarly you can do the decompression as well. And here's the important thing, like I have important note: to decompress any file using Huffman algorithm, you have to choose any file that was previously compressed using the same, because for Huffman decompression we need the frequency table, and if we are using any other algorithm like RLE, LZ77 or any other algorithm, I am not saving the this frequency table. So see, I have the this which algorithm was used. So this was compressed using Huffman. So let us select this, try to decompress it and see what happens. See, it is decompressed. The original size was this, the new size is this. As the result, the space shift is negative because it has basically its size is increased, so it is showing negative. So the original size was this, the decompressed size is this. This is the time taken. Here you can also again download the decompressed file, and the same thing, you can go to home, and it is totally mobile responsive. You can see for different screen. So now let's see the coding part. Yeah, so this is the repository in which I have my front end and back end code both. So first let us see the backend part. In the backend we have, this is the main source file, or you can say the root file, where you are setting these different routes for like if you want to see, like I'm not using this route anywhere, but if you can if you would like to, you can. No, I'm using this route in my home page, where I am showing all the which are the algorithms are available to compress or decompress, like these 4 algorithms. So this algorithm is used in the home page. This is the compression for, like when I try to compress any file, then this route is hit. For this is for decompression. Here are the routes. This is for algorithms, like forget any all algorithms. This is the compress. This is the multer upload. Like before compression I am uploading it to multer. For now I am uploading it to multer, like, but if you want to scale it and save it in cloud, like in S3 bucket or something like that. This is the decompress. Then these are the controllers, like compress controller. This is the file name. First of all I am saying the checking if the file is uploaded or not. If no, there is no file, then I am returning right away from here. Then I am extracting these data, like algorithm input buffer and input path, etc. These are the thing I am doing for CPU time measurement, CPU usage measurement, and RAM. And then I have this switch case for different algorithms. Then I am stopping my operations for this CPU time measurement, etc. I am saving it, making its file name response, making a response. And this is the thing that I am doing to save in my database. Basically this is my front end. My front end is next app, so here I have also API points. This is the front end API point to save the job in my database. Similarly for decompression also. And these are my algorithms. Like if you want to add any new algorithm, you can add the algorithm here. Then you can add in the controller, you can add new algorithm and do accordingly. So yeah, put I have make my backend very clear. These are the some util files. This is for Huffman. This is the stats calculator. Basically here I am calculating the compression ratio and times in millisecond. So yeah, and this is the front end. The next like standard file structure. Here I am source. These are some server action. This is the user. Basically authentication. For authentication I am doing this. And these are my, and I am using Clark authentication. So this auth route is for Clark, like when this is the redirection page on callback. Clark comes, and here see, this is the dashboard. Similar things. Here are some hooks, models. Here I defined all my types. Yes. So yes, so currently this site is hosted in Vercel, but if you want to run it in your local machine, then very simple, you have to do nothing but create an environment file for front end, create an environment file front end, and in the front end you have to put your clerk keys, secret keys, and publishable key. And you have to create an database in NeonDB. Like I have created in NeonDB and put the database URL uh, in the environment file, and you are good to go. And yes, that's all. So if you have had the sign out option, and all these are managed by Clark. So yeah, thank you.